Today's lesson is polar coordinates, okay? Our whole objective today is to convert between polar coordinates and rectangular coordinates, go back and forth. All right, well, first place you need to know what a polar coordinate is. Polar coordinates are used in use a completely different graphing system than the Cartesian rectangular. That's what you usually use. Rectangular coordinates are in the form of x, y. That's how you've been graphing all along. Polar coordinates are in the form r, comma, theta. Okay, polar graph paper looks like concentric circles or a spider web. The center is called the pole. Pole. R is the distance you move from the pole. And theta is the angle where you graph the point. 0 is in standard position just like it always has been. Okay? Just like when we did the unit circle, that's 0. All right? And your angles work the same way as the unit circle. If r is negative, this is important. R is negative, you're going to go in the opposite direction. Okay, so let's plot some of these. So the first thing you do is you find your angle, pi over 3, which is up here. The circles are where you count. So this is 2, so you go out to the second circle and plot your point. 11 pi over 6 brings me down here. I'm on the third ring, so 1, 2, 3. Oh, actually, that's 1, 2, 3, so I missed it. Be careful, you missed the little one. Okay? 3 and negative pi over 6. When the angle's negative, you just go in the negative direction. You go this way. Okay, so here's 0. Negative pi over 6 is down here, and 3 is 1, 2, 3. You'll notice that this point and this point end up in the same spot. And we're going to talk about that later, about how you can name a point using 4 different methods. Okay? All right, 13 pi over 4, that's bigger than 2 pi, right? Because 2 pi is 8 pi over 4. So if I take 13 pi over 4 and subtract 8 pi over 4, which is 2 pi, you end up with 5 pi over 4. So here's 0. If I went like this, I'd have 8 pi over 4, and I need to do 5 more, which puts me down here. And then you go 1, 2, 3, 4. Okay? And you just plot the point. Okay, this is negative 3 pi over 2. So this time you find your pi over 2. Instead of going 3 here, negative means go in the opposite direction. So I'm down here, 1, 2, 3. All right? This one, you're at 3 pi over 4, which is over here, but r is 0, so your dot is in the dead center. Okay, so the angle didn't matter in that case. Okay? Now, it says plot the point and then find 3 additional ways to write the same point. So if I go negative 3 pi over 4, that brings me up to here, 1, 2, 3. Okay? I could have also, because here's 0, I could have rotated this way. Oh, you know what? I did that wrong. Let me start over. Yeah. Okay, here we go. Negative 3 pi over 4 puts me down here. 1, 2, 3. Right? Now I could have gone this way and had 5 pi over 4 and 3. Okay. Or if you go opposite side, it's up here. So I could have done positive pi over 4 and negative 3, because instead of being here, I would go opposite direction. Or I can go all the way around this way to here and then do negative 3. So it's negative 3, and it would be, what, 7 pi over 4. You'll notice when you do these, you have 2 positive r's and 2 negative r's. You have 2 negative angles and 2 positive angles. Okay, so let's say we did this one. We need another example. Okay, so this was pi over 2 and negative 3. I could have done negative pi over 2 and 3, and I'd be in the same spot. Okay, or I could do this which is 3 pi over 2 and positive 3. Or, ooh, what's my negative one? So that was negative. This was positive. I need another negative angle. Oh, we did negative this way. I could do negative this way. Negative 3 pi over 2 and negative 3. So you have both of them are negative, both of them are positive. You have a positive and a negative, positive and a negative. Okay? I'm going to ask you to do that also. All right. Then, to convert from polar to rectangular. Well, remember, this is x, this is y, this is r. Okay? If I know, and that's theta. So if they gave you polar, so they gave you r and theta. Well, I know to find x, the cosine of theta is equal to x over r. So x is equal to r times the cosine of theta. And I also know that the sine of theta is equal to y over r. If I solve that for y, you get r times the sine of theta. Okay? So, and then if I do rectangular, remember this is x, y, and r. We know that Pythagorean theorem, x squared plus y squared equals r squared. And if this is theta, we know that the inverse tan of y over x. It says if theta is in quadrant 3 or, quadrant 2 or 3, you add pi. And we'll talk about that in a minute. We're going to use the unit circle. I'm going to give you pretty angles, so it won't matter. Okay? We want to convert from polar coordinates to rectangular coordinates. Plot the point in both polar and rectangular to check your answer. All right, so this is polar. It's got an angle in it. So I know that x is equal to 6 times the cosine of pi over 6. And y is equal to 6 times the sine of pi over 6. Well, the pi over 6, the cosine is root 3 over 2. So you end up with an x coordinate is 3 root 3. Okay. And the sine of pi over 6 is a half, so 6 times a half is 3. Well, let's see, what is 3 root 3 in decimal? 3 root 3 in decimal is 5. So if I plotted that, I want to plot this polar. You go pi over 6, and it's the 6th ring. So here's pi over 6. You go 1, 2, 3, 4, 5, 6. If I do this, 3 root 3 is equal to 5.1. So 1, 2, 3, 4, 5. 1, 2, 3. Are the dots in the same spot? If I pick this circle up and set it on top so that the pole was at 0, 0, the dots would be in the same spot. Okay? So we did it right. Okay, let's try this one. This is theta. This is r. So we know x is equal to 2 times the cosine of pi, and y is equal to 2 times the sine of pi. Well, the cosine of pi is 1, so that equals 2. The sine of pi is 0. So I'm at 0, 2, or, sorry. The cosine of pi, is negative 2. Boy, I'm making all sorts of mistakes. Must be late at night. Okay, so I'm over here at negative 2, 0. I'm over here at pi 1, 2. Are the dots in the same spot? Yes, they are. All right, let's do one more. So x is equal to negative 4 times the cosine of 3 pi over 4. And y is equal to negative 4 times the sine of 3 pi over 4. Okay, the cosine of 3 pi over 4 is root 2 over 2. So you get negative 2 root 2. Well, negative 2 root 2 is approximately, oh, I don't know, just a minute, let's see. 2 root 2, oh dear, no. 2 root 2 is approximately 2.8. All right, this is negative 4 times the sine, which is root 2 over 2. So, oh, this was negative. So this ends up being positive, and this one's negative. So my coordinates are positive 2 root 2 and negative 2 root 2. All right, so you're over here at 3 pi over 4. And you do negative 4, so that's down here. 1, 2, 3, 4. Okay, if I do 2 root 2, which is 2.8, and negative 2.8, my dot's right there, and they look like they're at the same spot. So we did good. Okay, now we got to convert these the other way. It says convert from rectangular coordinates to polar coordinates. Plot the point, both polar and rectangular, to check your answers. Well, remember, this is x and y. So r is the square root of x squared plus y squared. So it's the square root of negative 1 squared plus 1 squared. So it equals the square root of 2. Square root of 2 is roughly 1.41. Okay? And theta, inverse tan, of 1 over negative 1 equals inverse tan of negative 1. Well, which quadrant am I in? If this is negative 1, 1, I'm right here. Okay? That angle is 3 pi over 4. So 3 pi over 4 and 1.4 is right here. Okay? So my coordinates, when I got done, I should probably write them as root 2 comma 3 pi over 4. All right? R is equal to 2 squared plus 2 root 3 squared, which is equal to 4. And inverse tan of 2 root 3 over 2, which angle has a tangent of root 3? That would be pi over 3. So pi over 3 and 4 is 1, 2, 3, 4. Or 2, and then 2 root 3. What did we say 2 root 3 was? 3.4. So the dots look like they're in the same spot. Okay, this and this, this and this. Yep, and that's, and that. Yep, they're good. All right. R is equal to 0 squared plus negative 5 squared, which is 5. Inverse tan is negative 5 over 0, and that's undefined, right? You can't divide by 0, but I can graph that. Remember, this is 0, negative 5, 1, 2, 3, 4, 5. Okay. Well, what angle is that? That's 3 pi over 2, and that's 5. So I'm at 3 pi over 2 and 1, 2, 3, 4, 5. Or I could have done pi over 2 and negative 5. It will get you to the same spot. That one you just got to know. Alrighty? And that's all there is to polar coordinates. Go practice. Oh.